Welcome to the School of Cloud. We're going to learn BigQuery this week. I'm Jeff Williams, and we've got a code of conduct. I'm going to paste this over in the chat. Basically, be nice to everybody, and people are only here to learn, and that's why they're here, and that's what we should be talking with each other about or working on. It's trying to learn and grow. People ideally have a growth mindset, and they're trying to learn to get better and get more skills that they can use to do more things in this year ahead. So Intro to BigQuery is the first event we have this year. We've got 3 weeks on BigQuery, then 3 weeks on Intro to Cloud. Now, that might seem like the wrong order, but we've done Intro to Cloud before. We've had 13 events before this. So this isn't just the beginning. This is just kind of where we're starting off this year. We're going to do 3 weeks on BigQuery and get some database stuff out of the way. Then we're going to go back to kind of some of the basic pieces. And then we're going to go into networking and then into logging. And after that, we're going to go into some of like machine learning and data engineering and data science things. And we'll keep going through until we cycle through all the different parts of Google Cloud. And this is our Wednesdays. Here we go. So I'm Jeff Williams, the host tonight. There's another host that's normally with us, Elaine Chan, and she's unavailable tonight. I think there's a big snowstorm in Michigan that's affecting her plans. We've got a guest speaker, Ana Pilar Ysasi Cillero. I probably pronounced that wrong. Okay, you say your name.
You actually said it better than the average. Just use Ana. It's fine. Ana, it's fine.
All right. Well, anyway, she's a mathematician and physicist, and has a master's in analytics from the University of Chicago. And I'm very proud to have her as our speaker tonight. Now, when we're talking about the School of Cloud, we're talking about actually Google Cloud Platform. So this is an event series from the Google Developer Group Cloud Twin Cities in Minneapolis, Minnesota. It doesn't matter where it is because right now all the events are online and virtual, and I like doing things in this format. I kind of like being at home actually. In the old days I had to drive around so much and picking up pizza and drinks and whatever to sodas and whatever and cookies and things for the events. And yeah, it was nice to see people in person. But this format is also okay. It saves a lot of hassle. So anyway, Google Cloud Platform is one of the 3 big clouds. There are other clouds as well, like Oracle's Cloud and Alibaba Cloud. We're not talking about those. Google Cloud, Azure, and Amazon Web Services, AWS. Those are the 3 big clouds. Amazon is the largest, and then it's getting to be closer and closer between Azure and Google Cloud. And Google Cloud has some advantages. Azure has some advantages. Amazon has some advantages for different reasons. A lot of the people into data and data science things are into Google Cloud. Amazon had kind of like the first mover advantage. So they got some of the companies that went to the cloud very, very early. They're over there. And kind of new folks can go to whichever one usually is going to give them more free credits. Like all the startups and things. They're like, oh, $3,000 of free credits? Yes, I will use your cloud, or things like that. And Azure, they've got a lot of lock-in for Microsoft shops. So if there's a company that used a lot of Microsoft servers before, they're probably using Azure now. And you'll hear them say things like Azure AD. If you hear Azure AD, they're going to use Azure, and they're kind of locked in and stuck. So eventually Microsoft's going to make a lot of money from that. Anyway, enough about that. Google Cloud Platform has a lot of different services in different areas. Things about compute to get things processed, storage, big data, machine learning, many different areas. Tonight, we're talking about the one right down over here, BigQuery. Okay, one of many different services. Now, Elaine, who normally is at these Wednesday events, she came up with this awesome kind of salesy marketing image for us. So January, February, March. January, we're mostly doing BigQuery. The last week in January, we're moving on to Google Cloud Basics. And then the first 2 weeks in February, Cloud Basics. Then we're going to networking, kind of how networking works in Google Cloud. And then we're going to go to cloud logging. So first things first, we're going to log in. Sign out of Quick Labs if you're already logged into Quick Labs. We're going to sign into Quick Labs platform to get ourselves the free credits. So this is the link right here, but I've already pasted the link over in our chat on the side. So what I'm going to do is I'm actually going to repaste all of the instructions we need to follow over in the right-hand side, or let's see, is that going to work? Oh, that takes away the numbers. Okay, I'll go get it from the actual email. It'll take me 5 seconds or less. 4, 3, 2, got it. Okay, so that's the first 5 steps of the instructions. They're over in the chat. And then here's the second set. So the first step says, ask you to log out of Quick Labs. So if you're in Quick Labs, log out. If you already enrolled in the quest that we're doing tonight, then you'll want to unenroll in it so that you can enroll in it again. If you have no idea what this is, don't worry about it. The quest we're doing is the quest Bigquery Basics for Data Analysts. And that's going to be a free quest for us if we do use the code that we provide today. So I pasted the link for that. It's down at the bottom right after point number 10. There's a link there. quicklabs.com/quests/69. There are two different quests that you could work on that have some labs in common. One of them is the one that ends in 69. The other one ends in 123. Those two, you can kind of get double credit for the labs that we're going to do today and for the labs from next week also. Well, at least one of the labs from next week. So you can then kind of do like 2 labs and get credit for like 4 because it'll be towards 2 different badges that you can then put on your LinkedIn. Okay, so let's see, they say direct your attendees to open in incognito window this page. Okay, copy that link, paste that link. So there's one here, the Cloud Study Jams 2021. Now I know it says 2021. That's still what we're using. They didn't give me a new 2022 link yet. When you go to this page, I'm going to share this page now instead of the old page I was sharing. Okay, so I will stop sharing this tab and I'll start sharing the other tab. I'll just share my whole window. It'll be easier. Okay, so if you see the Cloud Study Jams page right now, the one with the 2021, they've got infrastructure, networking, applications, machine learning. Okay, we're looking for BigQuery. Down at the bottom, there's this more ... And over here, there's big data quests. And the first one there says BigQuery Basics for Data Analysts. And that's the one we want to do. It's the first of the big data ones. So if you click that, it brings you to a page that then asks you for a code. If you don't have an account yet on Quick Labs, it asks you to make an account. On the page to make an account, there's an option here. I'll show you. There's an option to use a Google sign-in. Most of you I saw in the registration had a Google account that you used, so just use that. Click the sign in with Google. Then in the box that comes up, paste in this code. Now this code is over in the chat. That one S Minneapolis 1997. I'll just paste it at the very bottom to make it easy. Copy it. Oh, and Ana beat me to it. So that's the link that we need to use to get access to the study jam, and then that'll get us access to be able to take the first lab. When we pass the first lab, then that'll unlock the rest of the month of access of Quick Labs. And then if you complete the entire quest that we're working on, then that'll get you a whole extra month as well. So then you won't have to do this for 8 weeks as far as like signing up again. So this is just the one-time setup that you do at the beginning of each month. And then once you've got the access, then you just use that month of access. When you get to the next page, it might ask you if you want to opt in for promos. If you want to get that bonus month, then you do want to check the checkbox about the promos. If you don't check the checkbox, you'll still get the first month free, but you won't be able to get that second month free. Basically, they want your permission to send you an email close to the end of that first month that says, hey, good job. Here's your, here you can click for a free bonus month. So you want that. So if they ask for it, check that little checkbox to opt in for promos. Once you've done that, you won't yet see monthly subscription. You don't see that until you finish one lab successfully. So you just started, so you haven't finished them yet. But if you have it from using it in the past, then you might still have credits from before. Sign into the account. And then later, when we start the labs, it'll say use subscription, or it'll say use credits. The first time, the first lab, it's going to say use credits. After you pass that lab, then it should switch to say use subscription on the next one or the one after. If it doesn't, then you might have to close Quick Labs and open Quick Labs again. And here's what we're hoping to get. We're hoping to get this completion badge. And that's what we're working on these 3 weeks. If you go ahead and make it through this early, great. Come on back and help other people who are getting stuck. Or if you don't want to finish the quest, if you just want to do part of them or just a couple of the labs, no problem. It's up to you how far you want to go and what you want to get out of this. Okay, so now I think the next slides are Ana's slides. Now let's see how people are doing and if they need help, and I'm ready to help if they do. I've got a link that I can paste in the chat to, I've got my own separate meeting going, a Zoom, and you guys can join that Zoom one-on-one if you need help to have me help while Ana is busy presenting. So that's kind of what I'm thinking. Ana's got the slides, she's getting ready, she's shared her screen. We're doing great.
Okay, so if anyone have any questions about logging into Quick Lab and all that, Jeff will be onto that, but you can talk at any point, stop the lab or just write on the chat. I'll have it here. I should be able to see it. So what we're gonna do right now is we're gonna start introducing what Bigquery is, and then from there we're gonna go to introducing SQL and a little bit of the introduction of the syntax that we use for querying with SQL. We're gonna take some time here before we even go to the lab. So once we go to the lab, because as Jeff just said, we're gonna spend 3 weeks doing this. We can get the most of these 3 weeks using Bigquery and so using SQL. So let's go on to it. So Bigquery, the definition itself is, I think I lost my audio here.
You're muted, but earlier when you said that you had lost it, actually I could hear you just fine. But right now you're muted in the Quick Labs page, so you'll have to go back to the Quick Labs and choose to unmute. Okay, you're unmuted in Quick Labs.
I'm good now?
Or not Quick Labs, I mean in the GDG event platform.
Am I good now?
Yes.
Okay, sorry about that. I have no idea what happened. So Bigquery is, I lost it again.
Okay, looks like she popped out. She's going to pop back in and share, and that's okay. All right, she's sharing the slides.
Okay, sorry about that. I lost the thing. I don't know what's going on with my audio. Let's just go without it. Can you hear me now properly?
Yeah, that's fine.
Good. Sorry about that. So
it was a little better with the AirPods, but this one is fine. No problem.
I'm gonna try one last time. But otherwise, no, I think it's my internet. I have no idea what's going on.
All right, so she's going to try figuring out about her audio, and that's okay.
I think what's going on here is my internet. I have the cable, so it should be working fine, but for some reason it's not.
Well, maybe the first choice is to not share video, so then you don't have to have that
Yeah,
and just
yeah.
do audio and the slide share, screen share. I think that'll be perfectly fine.
Yeah, I think I'm just gonna go for that for now. Sorry about that. I really hope I don't lose you again. So just in case, let me talk a little faster this time. Um, so what is BigQuery? BigQuery is a fully managed petabyte scale data warehouse. So what does this sentence means? It basically means that storing and querying massive data sets. When I talk about massive, I mean petabyte scale, which is a lot of data. Curing and storing these is first very time consuming, and then it's also very expensive. You need the right hardware, you need the right infrastructure, and having that, it's very expensive again. So BigQuery basically solves this problem by enabling a super fast SQL query using the power of Google Cloud. And finally, I have here this little schema right here that now in the slides we're not going to understand very well, but it's the hierarchy that is very important in BigQuery. It goes project, database, and table. I'm not sure if you're going to.
We heard you said project and then database and then table.
Okay, for some reason I lose the audio in here, but I'm just gonna keep talking because I think you can hear me. So basically, we have project, we have dataset, and we have table. That is very important later for when we're querying with the um, in in BigQuery. So SQL is a standard language for data operation that allows us to ask questions and get insights from structured data sets. So what does a structured data set means? It means that the data sets, the tables, have a certain rules and formatting that it usually is structured in rows and columns. The contrary of this would be unstructured data, which would be, for example, images, would be videos, documents, web pages, audio files. So they don't have this structure of rows and columns that allowed us to use SQL for get insights with them. It is very common to for petabyte scale data analysis and also for transaction record writing. So after this little introduction, now we are gonna go to. I really hope you can hear me, guys, because I cannot hear anything right now. I don't know what's going on. But anyways, we're gonna start now with some of the syntax, and we're gonna start with the most basics, which is select and from. So we use select to specify what fields we want to pull from our data set, and then we use from to specify where to get the data from. Sometimes a data set has a lot of tables, and we use from to specify which one of the tables we want to take. So let's say, for example, we have this one example here. We have a table with the user, with the price, and whether the packages had been shipped or not. And let's say that we want to get this user information, only the user information from the table. So the query that will get us that information would be select. Now we're selecting the column user from this example table right here. This would give us the information right here. Let's say that now we want to get both the user and whether the package had been shipped or not. In this case, we need to add the shipped column into here. So we would have select, both columns separated by a comma, so user and shipped, from, and then the example where we're getting our data from. If we want to select all the information, we need to do, this is a little different from before, but we need to select start from the table. This would get us all the information on the table. Do we have any questions for now? Because I cannot hear, I would really appreciate if you write it on the chat directly. So the next statement would be where. So we use where to filter specific columns specific values in the column. So for example, let's say that we want the names of the people whose packages were shipped. What does it mean that the packages were shipped? It means that in this column in here, we're looking for the value yes. And what we want is this user information right here. So what we need to do is we need to select user because it's the information that we want. We want the names of the people from example table, which is what the table that has the data that we're looking for. And now we are gonna get the information from this shipped column, but we only want the values that have the yes right here. The output of this query would be a table like this, which is exactly what we want. The names of the people whose packages were shipped already. Let's go for group by. Group by, it's a little tricky, but once we do an example, it's very easy to understand. So what does group by do? It aggregates the result set rows that share a common criteria and will return all of the unique entities found in such criteria. So let's say, for example, and it's very useful to figuring out categorical information tables. So for example, in here, in the ship columns, we have two categories. We have, yes, the package has been shipped, or no, the package has not been shipped yet. In this case, we only have two, but we could have way more values. We could have null values. We could have, for example, in process, or we could have way more values, and we use group by to get those unique categories inside of a column. So let's say I want to know what are the different groups in the ship column. In this case, it's just yes and no. Yes would be the categories in blue, and no would be the categories in yellow. So how do we do this? I'm going to select the ship column, which is because it's the information I want to get from the table, which is example table, and I'm going to group by ship. And what is this going to do? It's just going to give me the different groups in this column shape, which in this case are just yes and no. This is very useful with other statements, like for example, count, which returns the number of rows that share the same criteria. So let's say that now we want to count the number of packages that were shipped and the numbers of packages that were not shipped. We have from yes, we have one package in here, 2, 3, and 4. And for the packages that were not shipped, we have them in yellow, which are also 4 packages in here. So how would we do this? We're selecting first the ship column, which is the one that has the information, the yes and no. And now we're going to do count. We want to count the rows with the criteria. The criterion here is, are they shipped or are they not shipped yet? So from the example table, that is the one that contains the data. And now we're going to group it by this column ship. What is this going to return? This is going to return the 2 categories as we did before, yes and no. And then the number of rows that we have that follow said criteria. So we have 4 of each one in this case. Bear with me 1 second with this F0 right here. I'll explain why we have it in a second. But let's get now something a little more challenging. So this right here is the query that we had before that was giving us the count for both categories, the yes and no. Let's say that now I only want the number of packages that were shipped. What am I missing here? How do I get only these 4 results in here? Again, if you can type, because I cannot hear absolutely anything.
Add a where condition.
Exactly.
And
We
ship
add a
this
where
equal to yes.
condition. Exactly. We add the where clause, just saying, okay, where ship is equal to yes. This would give us indeed this table with only yes and 4. So you remember how I was talking about this F sub 0, right? 1 second. So count is very useful. It's the only one that we're using this first lab that we're gonna do here. But if you guys are gonna continue later on with the rest of the labs, there are other statements that are very useful and that are used using the same way, which are average, max, and minimum, and they do basically what they mean, which is this is the average value of the column that we're calling, maximum value and minimum column. They work just exactly the same way. We can do some examples later if we have some time. So as I was saying, we have this F0 underscore right here. And this comes because we didn't give any name to this column that we created, and it doesn't come directly from the data. This count star right here, it's directly called as F0 underscore. If we had more columns, it would be F0, F1, and so on. So we use the as statement to create an alias of a table or a column. So to call this table, I will need to use count star as num_ship. And this table now would have these two names like this. Does this make sense so far?
Yes, it does.
Good, glad to hear. So this is just the last statement that we have, the last keyword. Order by, we use it as, again, as the name it is telling us, to sort the return data in ascending or descending order based on a criteria. So the ascending order is the default one, meaning if we don't specify anything, it's gonna return the values in ascending order. So for example, now we want the prices of the items from lowest to highest. So of the shipped items. So again, these are the shipped items. And now we want to return them in lowest to highest. So we would have 20, 35, 55, and 65. So how do we get this? We're going to select the both columns that we want the data from, the price and the shipped. And now from this table that we have right here, and now we're going to specify, we want the ship returns, the ship packages. So where ship is equal, yes. And now we're going to add this last one sentence, order by price. When we do this, it's gonna return all the values from lowest to highest, just like this. We'll do it later when in the lab. But if I add ASC from ascending right here, it would return the exact same result. But because the ascending is the default, we don't need to add that. If we want it in the other order, we want it to, from highest to lowest, being 65 the first value and 20 the last one, we need to add right here descending, and this will give the values in the other order. And I think this is all we have so far for the intro with the slides. Does anyone have any questions before we go to the lab? And then everyone has the credits that Jeff explained already, because otherwise I'm just gonna jump on it, and I hope everyone is with me so far. So if you did as Jeff explained, you should have now the lab. So we're gonna click on here on start lab, and because I've done this before, I'm just gonna launch with 1 credit because I have a lot of credits right now. And in a second, it's starting. Well, I'm definitely not a robot, so let's see. I'm actually pretty bad at doing these things. So this is a bus, this is a bus, this is a bus here too. Okay, verify. Okay, launch one with 1 credit. Perfect. So now this is gonna appear right here. Now we're clicking open Google Console. We copy our username. We're gonna do on user another account. We copy the username. Now we're gonna copy the password. And now we are in. So let me put this in here for me. So here is how Google Cloud looks. For people that haven't logged in, you probably have to click accept and a couple of things here and there. So this is the lab that we're gonna be doing right now. I'm just gonna send the link again just in case someone doesn't have it. And I'm gonna give a second so people can log on it. So basically this entire first section that we have right here is what we've been seeing so far. I actually use the exact same table right here. It started explaining how we use select, how we use the clause where. And now let's our understanding while people are kind of like getting inside the lab. So a keyword that specifies the fields, so the column values that you want to pull from. Is it from, select, or where? Exactly. I was like, if people don't get this, I definitely did something wrong. Good. So now it specifies what table we want to pull data from.
From.
Exactly. And lastly, allows to filter data.
Where?
Exactly, perfect. Thank you very much. So let's start now with the lab itself. We are gonna start exploring a little bit of the console here, the Google console. We're gonna navigate down here to the section that says big data. So right here we have big data, and in big data we have BigQuery. I always pin the BigQuery because we're gonna be coming and going all the time, so it's easier just to have it up here. So I'm just gonna click on it, and once we click on it, there's a couple things, interesting things to look for people that have never used BigQuery. So the first thing is the editor right here. In the editor is where we write our queries. So here I would say select everything from, whatever it is. Here we write our queries right here. Then we have right here we have saved queries. What is saved queries? Let's say I write up, we can say later on, once we start doing a queries, it will probably be a little easier to understand what I'm talking about. But saved queries right here is, let's say you write a query and it's very interesting, and for some reason you think you're gonna use it later on again. So if you save it, then you have the information here to come back, and you can see the results again without having to compute it again. With this, every time you press run, every time you compute something, that costs money, because like you're running something, you're using a computer that is not yours, it's Google Cloud. So by saving the queries, you would have access to them later on. Project history would have recorded all the queries that you've done. You don't have them saved, so you have to run them again, but you have all the project history, all the queries that you run. I don't know how familiar you're with Google Cloud, but our project would be this right one here. But if you have your own account, you can have multiple projects. Right here, for example, we have our own project, and then we have another one right here called BigQuery Public Data, which, don't worry guys, you should not have these right here. I have it because I've done this before. But anyways, and then personal history would be for all the different projects that you have. Finally, just a little bit more about the BigQuery console itself. Right here we have the Explorer Lab. As I was saying, here we have the different projects inside. Inside the project, you remember these that I said before about project. We have project, we have dataset, and then we have tables. So this schema that we have right here, we can see it in here. So for example, BigQuery Public Data is a project. When we open it, we have the different data sets. Austin_311 is a data set. Inside here, we have the tables. This right here is a table. So this is how BigQuery works with this hierarchy that we explained before. So this means that I think this is a little bit of the explanation in general of the console. And let's go now to the lab itself. So in Explorer right here, we're gonna click on Add Data, and now we're gonna go to Explore Public Datasets. So once we go to Explore Public Datasets, we're gonna click on London. We're gonna search for London, and we're gonna go to London bicycle hires. We're gonna click in here. We're gonna see on click View Dataset. When we open this, if you have ever used Google Cloud, it's gonna happen what it just happened to me right now. It opened on my own personal account. I don't want that. So what we need to do right here is change to the Quilab user that you have. Once you enter into this, you should see right now this BigQuery Public Data right there. Is anyone lost? Everything good?
What did you do to get to that? Because I opened in my account.
Good. So you need to click right here on, you see the avatar right here, and you need to switch to the right account. Just click on it.
All right.
Once you click on it, you should have these right here. So if you come back, for example, to the page that you were before, I don't know what this happens, you use recharge, and you should have both your project and BigQuery Public Data. You should see both now.
I'm just seeing like the QuickLab GCP one. There's no BigQuery on mine either.
Can you, did you recharge right here?
Wait, what do you mean recharge? Like,
Sorry, reload the page.
yeah. So from the home, you want me to go to the Google Big Data Analytics, right? The BigQuery.
Yeah.
So if I go to BigQuery, then I just have like
You only see your project right here.
Yeah, the GCP one. There's no BigQuery one.
Good. So if let's just go over again. So click on Add Data, explore public data sets. Now you go to London right here. The bicycle hires.
Wait, how did you get that?
Yeah. So my bad. So Add Data right here on the corner with where it says Explore. Now you click on Explore public data sets.
Public data sets. Yep.
Good. Now you're gonna write in the search marketplace, you're gonna write London and click on London bicycle hires right here.
Got it.
And now click on the result that appears, London bicycle hires.
And view data set.
And now you click on view data set. Now, as Kristen was saying, if you have your own personal account, it's gonna open with it. Make sure you click on your avatar and you use change users right there.
Got it. Thank you.
Can you see both of them now?
Yes. Thank you.
Awesome. Okay, perfect. So I hope everyone is on the same page. Now that we are on the, that we can see both of them right here. What we're gonna do is we're gonna navigate to the table. So how we do that, we're gonna open all the tables that we have right here, and we're gonna look for the data set London bicycle. So we go down, more results. No, I passed it here. In London bicycles, right here, we open it and we have two different tables. We have cycle hire and then cycle stations. We're gonna click on cycle hire. So we have a lot of things going on right here. The first thing that we see is the schema. The schema is very important because it tells you a little bit of information about the table before even seeing it. So here we have the different field names, so the different column names, which are rental ID, direction, bike ID, end date, end station, and so on and so forth. Then we have the type of data. Integer, we have timestamp, we have some string values, and then we have whether they're required or not. This is a little more, you don't need to know these, but anyways, it's some of the values like rental ID, for example, they cannot be null. The other ones can afford to have null values. And then this last thing right here, this is super useful if you've never seen the table. If, for example, it's telling you that the duration is in seconds. So let's say that you want to see what trips are, in less than a minute. You would have to put less than 60 because everything is in seconds. When we go to details, we have a little bit of details of the table. So we have the table ID, which we have in project, then we have dataset, and then we have table. This is how it works. This is the ID. Then the table size then we have the number of rows. This is a bunch of rows. This is 24,000 rows, which is a lot. And then this was created in July 2017, but the last time that was updated was in May 2019. This table never expires, and the data location, because it's in London, is Europe. If we preview the data, now we have right here how the data looks. So doing this is equivalent to do select a star and then from and then calling the table, because here we have all the information from the table. So let's start doing some quick queries here and there. So sorry about that. So we're gonna, I usually like to see the table while I'm querying. So in order to do so, I'm gonna click on query here. I'm gonna do split tab so I can see the table while I'm writing the query. You can use writing here, or you don't have to share. I just usually like to see both things at the time. So we are gonna start by selecting the column A station. So how do we do this? We saw it before that we're going to do select. We're going to call the name of the column that we want to select, and now we're going to call the table. How do we call tables in BigQuery? To call a table in BigQuery, we need to go to the table ID that we have right here. So we basically need to go to the project. We need to call project name, then dot, then the dataset name, then dot, and then finally the table name. So once we do here, if we select it and run it, we're gonna see that we have, one second, this is running. Then we have 24,000, well, a little more than 24,000 rows is the result, which is exactly the same as the number of rows that the table has. So let's now make it a tiny bit more complicated, and let's try to see now what bike trips took longer than 20 minutes. So I'm gonna recycle what I used before, but now I need to add that. So if I'm filtering, what I'm using here is a where clause. And now I'm talking about time. So now I'm gonna see here and I see the duration talks about the second. So I'm gonna filter by the duration. I need to be greater than 20 minutes, and that would be in second, 1,200 seconds. So let's see how many results we get this time. In this case, we get around 7,000 results. So basically, at the beginning we had 20. Where are you? So 24,000, and we got this time around 7,000. So around 30% of the rides take more than 20 minutes of time. So that's an insight that we got there that is already pretty interesting. So let's test our understanding, because we already saw a little bit of all that. And now a fully managed petabyte scale data warehouse that runs on Google Cloud is
BigQuery.
exactly. Project contains datasets and dataset contains tables. This is exactly, Kumar, this is true.
Mm-hmm.
And now with BigQuery, you can access dataset shared publicly from other Google Cloud projects. This would be
false, right?
No, this is true. Why is true? What we have right here, you see this BigQuery public data. This is data shared publicly by Google, and we are accessing to it, and we are actually like querying with it. You could do exactly the same thing if you want to make your data set public. So this would be true.
But to make my data public, do I have to send it out to Google and then have them publish it?
No, not at all. You just, well, that's a little more, we can see it later once we create a table, but you basically need to use, when you share your data, you have restrictions on the data, and usually only you yourself can see it. Mm-hmm. Or if you have, for example, a project, everyone that is in the project can share it, but you can also make that data public. So there is a way to make it public. You don't need to ask anyone permission. You just can make it public. And anyone with that access to that project would be able to like publicly just see it.
But it wouldn't still come under the public data category, right?
No, it would never be here. This is just Google's data.
Oh, okay.
If that's your question, right?
Right.
Yeah. No, this is Google's data. You cannot mess with this.
Okay.
Yeah.
And we cannot contribute to that also.
I don't want to. I'm not sure, but if I had to guess, the answer is no, because this is Google data.
Okay.
Yeah. So let's go to a little more complex statements that we also saw before, which are the group by, count as, and order by. So let's now select the different start station names. So when I say different start station name, basically what we're trying to do is get the different classes, which are the station names, in the column that we have right here, which are station name. So how do we do that? Does anyone know what's the tricky statement that we need to use right here? Anyone?
Can you repeat that question once again?
Yeah, so we're trying to select the different star station names. What keyword do we need to use to get that?
Distinct.
Yeah, well, that I was gonna get to that later. That's the easy way to do it. But with the statements that we've learned today,
Group by.
exactly, because we're gonna get the different classes. The thing is that we have so many classes in here that it seems that it's a little different. So basically, what we're doing is we're taking this one column, and we're grouping. So let's say we have this repeated 1,000 times. It's only gonna appear one. So let's see what we get right here. We get 880 results. There are 880 results, which are the different station names. But as I'm not sure who you said the distinct thing. I didn't catch the name. Okay, so as Nathan said, there is another way to do it, which is just using here distinct. So what we're saying is select all the distinct start station names from this table. This is not in the lab, but I think it's very useful to know that you can also do it like this, and we're gonna see how we also get indeed 880 values. So exactly, this is the same results right there. So let's not use the count. Let's see how many. So here we have the different station names, but let's see how many people started on this station. How many people took the bike from this station? So let's recycle this that we have right here. In this case, I'm interested now in using the group by instead of distinct. And now what we need to do is add another column, which is gonna be count, and we're gonna count everything. This is gonna give us the different stations. So let's run this right here. I'm selecting because I only want to run what I have selected. If I didn't select, all the different clears will run one after the other one, and I'm just not interested in that. So right here, I have in this station, which I'm not sure I can pronounce, there almost 75,000 people took the bike from. Now, do you remember when we talk about this F0 underscore right here? Why is this happening? Like, what didn't I do to get that right there? What am I missing?
There's no defined column name, so probably give an alias name.
Exactly. So if we get an alias, for example, you say, let's call it just num. I think that's how they call it. I don't remember right now. If we just change the name to num station, for example, and I'm start because we also have n. Now we run it again, and the exact same result is going to appear, but now the column is going to have a more descriptive name. This is very, very useful to do when you're sharing your results. It's always good to have descriptive column names for people to understand what is it that you're doing. Okay, now we have this column in here, but let's organize it a little bit. Let's say that I want now the exact same thing, but I want to order alphabetically. So if I want to order alphabetically, what do I need to do? This is a little trick. I didn't say this explicitly before.
Order by.
Exactly. So now we're gonna order by, and if I order a column that has strings instead of numbers, what it's gonna do is it's gonna order alphabetically. It's gonna go from A to Z because it's in ascending order. If I wanted the other way around, I would need to write descending. So we can see here how we have it in ascending order. If we go to the very end, if we go to the last results in here, we see indeed how this is, WY. So this is order now. let's say instead of wanna ordering by the name, I wanna see I wanna order from lowest to highest. So how would I do that change? How would I get this result?
Descending.
Um,
Order.
Sorry?
Put a descending at the end.
No. So actually, the first thing I need to do is right now I'm ordering a station name. What I'm gonna order right now is by this
okay.
column right here, right? So
Yeah.
I wanna order by this column right here, and because I want it from lowest to highest, this is actually ascending, which is the default. So let's see right here, because it's the default, I don't need to write ascending, but let's double check now that we get the same result. So let's run this now. And we're gonna get that the first columns that only has only one people, well, this is kind of sad, only one person started the right here in LSP1. Then we have Penton Street, and then we have LSP2. So now let's double check that indeed ascending is the default. So let's see what happens if we add ascending right there.
Should give the same.
Exactly, we get absolutely the same. But if we want to do the other way around, now let's say we want it from highest to lowest, what do we need to write instead of ascending right here?
Descending.
Exactly, we just write descending. And now let's see what are the most popular star station names. The most popular star station names are, well, these ones, because they have the most people starting their rides right there.
So when you said the name, when you pass the column, right, it picks up, it goes by ascending order.
Yeah.
It goes by alphabetical order, right, if it's a string.
Exactly, it goes alphabetically, yeah.
How is that determined? If a number is saved as string, would you still be able to get that same functionality?
No, if it has names, so for example, let's say you had, it could be still a string. So let's say we have right here, if I put this is because it's a string, let's say I say I have Ana, and then I have Ana underscore 00, and then I have another value in that column that is Ana underscore 01. So
and
both,
say you have 01 Ana, or just 01 in the value.
what do you mean?
Just a number one in the same column.
Yeah, so what I'm trying to say is that what Bigquery would do is it's gonna start ordering alphabetically, because it's this is a string, right? So Anna is gonna see that this is the same, then underscore is the same, 0 is the same up until here, both are exactly the same, and then it's gonna come to 0 to 1, it's gonna treat it as numbers. So this row, if this was a row, this would come before than this. So if these numbers start instead of integers or huge integers, they are strings, you will still treat them as numbers, even though they're strings.
Okay, yeah, thank you.
Of course. So let's go through a quick test right here. So what keyword aggregates rows that share the same criteria and will return all the unique entities found in such criteria?
Count.
Say that again. So we're looking for a keyword that aggregates rows.
Count. Or yeah.
Well, let's see. Let's click on count because we have a majority here. This is not right. We're not counting. We're trying to
group by. Sorry.
Exactly. We're trying to aggregate the rows that share the same criteria. Do you remember we had that at the beginning, that table with yes and no? The same criteria is that all of them have yes, all of them have no. So that would be what would make the difference. You see?
I think I was confused with that aggregation word.
Yeah, aggregate is equal to sum. Yeah, I get that. Now SQL function that will count, well, they basically told you, but anyways, and return the number of rows that share the common criteria.
Count.
Yeah, this one is easy. And now creates an alias of a table or a column. As
yes.
Awesome. and finally sorts their return data from a query in
Order.
ascending order. Perfect. This is just ordered by. Good. So now let's do something. So you know how this is introduction to SQL from Bigquery and Cloud Sql. So in Bigquery, we said it was a fully. Let me see the definition exactly before I messed up. It's a fully managed petabyte scale data warehouse. On the other hand, Cloud SQL is a fully managed database service. It's a little, this is a database, the other one is a data warehouse. There's a tiny bit difference in there. So we're gonna now we're gonna create now our a database in Cloud SQL. So let's go back to the console. So let me explain a little bit what we're gonna do now. So in the console right here, we're gonna create two data sets. We're gonna get a result right here, and we're gonna save those results. Then we're gonna go to Cloud SQL, which is another server, and we're gonna upload those results and create a database right there. So let me not get ahead of myself and do this little by little before I confuse anyone. So if we go to the lab, it tells us to copy and paste this query right here. Let's see if we can understand what the query is telling us. There you go. So let's format this a little bit. So we're selecting the star station name, and now we are counting the number of people that live from the star station name from this same table that we were working, and we're gonna group it by, so we're basically doing the count, and now we're ordering by descending.
Hi, I have a question.
Of course.
How did you get these two panels side by side, the schema panel and
Yeah. So I like doing this to kind of see the detail and what I'm doing. I think it's a little more easy. So once you navigate through the Bigquery dataset, you're gonna find London bicycles. If you open it, you have cycle hire. When you click on it, this is gonna appear right here. So
yes,
now you can. This is 1 second. Let me just copy paste this and close. It's fine. If I click now on query right here, I can do in a split tab, and now I have both side by side.
Okay, thank you.
Of course. So as I was saying before, now we need to run this query right here. So what does this query do? Let's see if people understand kind of like what we're doing before I run it. So what we're doing right here is we're counting the number of people that left from the star station, from each one of these stations, and we're ordering the results from highest to lowest. So let's run it to see if I'm right. That's what we're doing. Super important. This is actually pretty nice that Bigquery has. So can you see how I have a green check right here? This is because the query is it's okay. If I for example, let's say I don't write the last part, which is the table name, this is incorrect right now because I'm not selecting the data properly. So it's telling me that it's this query is wrong. So this is very useful to kind of like double check if what you're doing is right or wrong. But anyways, so let's run this query right here that we have. And now once it runs, we're gonna click on save results. Can you see my screen? Is my screen frozen?
Yeah, your screen is visible.
No, it's good. Okay, so we're gonna click on here and save results. And now we're gonna save it in a local file. We want it on our computer, and we're gonna click on save. And we're gonna have a download right here that these are the number of bytes that left from the star station name. So now let's do the same thing, but instead of doing with the star station name, let's do it with end station name. We have all these queries. You have all these queries on the lab. Let me make sure that it's also okay from descending order. Good. and we run it. Now we're gonna do the same thing. We're gonna click on save results, and now we're gonna say we want it in a local file because we want it on our computer, and we're gonna save it. So now we have these two downloads. The first one is gonna be the start station, and this second one is gonna be the end station. So is everyone with me? Because now we're gonna go to something a little different.
That's a good question. Like, are we going for the Google Drive?
No, we're going for a local file. We want it on our local file. So when you click on save results, make sure you change it to local file.
Got it. Thank you.
Because otherwise it's gonna be saved on the drive, but it's gonna be saved on the drive of your, of your Quilabs thing, and it's a little, like just downloading your computer. It's not a big deal. It's a pretty small data set. Good. So now what we're gonna do is we're gonna save this data in a Google Cloud bucket. So let's click right here in the navigation menu, and we're gonna navigate to cloud storage, which is gonna be right here. I always pin it because we use it all the time. And now we're gonna go to browse. So cloud storage, browser. When we go to browser, we're gonna click now on create a bucket. And the buckets need to have a global unique name. What does global unique? Oh, this is bad. I need to charge my computer. Give me 1 second. So what does global unique name means? It means that no one can have ever used that same name that you're using right now. So probably, yeah.
So should we use a name like Bob or George or?
Yeah. So that's a good question. If you use those names, I don't want to say 100% sure because I haven't tried them myself, but I'm almost positive they're not available. Why? Because someone already used them. Let's say I use Anna. That bucket name is taken. This means someone already has a bucket which name is Anna, and that's the reason why I cannot use it. It needs to be globally unique. No one can have ever used that name. So what I'm gonna do to make sure it's unique, I'm just gonna use my GCP project ID, which is also unique. And by copying this ID, I just can, I can come back to that name very easy, and I make sure it's unique. And you see how I don't get an error right now. So, now let's leave everything default and just click on create. So here it is. We have just created a bucket with our project ID name. So let's go right here. We're working with cloud, and let's see our progress. So we have already completed we have already created a cloud storage. So let's see, check my progress. Indeed, we have the first part of the lab completed. So next, now let's upload the data that we download previously in our computer. So we're gonna click now here in our bucket. We're gonna click on upload files, and we're gonna upload both files that we just downloaded locally. We open them, and here they appear, both of them. So I don't remember who asked me before, how do you make something public? If you click on edit access, you can make it public, but again, I wouldn't do it because you have to pay for that, and it's a whole thing. But anyways, you can make it public just like that. Anyways, let's now change the names. So 645D8 was the file that I uploaded before, like the first one. So it's the start station, and the one that I downloaded secondly is gonna be the end station name. So basically 645D is this one. This is the start station name. So we're gonna click on rename, and we're gonna call it start station data.csv, rename. And now the other one, which is 63 something, we are gonna rename it and name it end station data.csv, rename. So here we have the two data sets, and now let's go to the lab and let's see if we did it right. Check my progress. I completed properly. Let me double check that everyone is on the same page. Is everyone okay?
Sorry, how did you rename that?
Yeah, so come here to your bucket and you click on the 3 dots right here and you just click rename and you just change the name right here. Is everyone okay so far?
Good, thank you.
Good. So now we're gonna go back to the Cloud SQL and we're gonna create an instance there. So what does that mean? Let's go back to, Let's now go to down here, databases, and we have SQL. So let's open that. In here, when you go to navigation menu, databases, and you click on SQL. We'll go to SQL and we're gonna do create an instance. For my instance, we want my SQL, so we're gonna choose my SQL. And now we're gonna create the instance right here. I'm just gonna call it the same way they did because it's gonna make it a little easier later. So Quick Labs score demo, that's how I'm gonna call my instance. And we need to put a name, a password. I recommend you to put a really easy password because we're gonna need it later. So don't forget, I'm just gonna do 1111. So definitely not very secure, but I need this later. I'm just gonna put an easy password and we're gonna leave everything as default and just we're gonna do here create instance. We see creating Quick Labs demo, the instance being created, and this is gonna take a second now. So is everyone okay? Because again, this is gonna take a couple minutes, so we have a couple minutes now.
Anna, can you walk us through this creating of this instance one more time?
Oh, of course. So come right here to the navigation menu. And now navigate to databases right here. In navigations, you have SQL. So click on SQL. And it's gonna open something like, well, I already did it. But you're gonna have to click after that on MySQL. It gives you 3 options: MySQL, Postgre, and something else. So click on the first one, which is MySQL. And once you are there, you're gonna click on Create Instance. Are you there?
Maybe I missed it. I didn't see when I clicked on the navigation menu, you said databases.
Yeah, sorry. Yeah. So here you have databases right here.
Oh, database.
You see, and at the end of databases, you have SQL.
Google, you also always have the option up in the top bar in the top center. You can just type in SQL.
Right here.
It'll show and it'll be the top choice in that list. They love search over there at Google, so they usually make it easy to search for things also.
And
You don't have to manually
select
scroll.
MySQL.
Did you find
MySQL?
Yes.
So let's look into that. So let's write SQL. Looks perfect. Right here, the first one, SQL. There you go. Thank you, Jeff. So once you click on SQL, you're gonna see this right here. So click on the first one. Are you with me? I think it's.
Yeah, I can see this. I'm on that. I clicked on.
Perfect. Now click on
instance.
choose my SQL. And now you have this information right here. For the instance name, I recommend you to use the one that they're using right here, which is Quick Labs demo. You put that right there. I already used a one, so it's not gonna let me. Then use a very easy password because we're gonna use this later, and just click on create instance right here. Is it are you creating the instance right now, or it give you any problems?
Yeah, I just clicked on create the instance. It's building up for me. Right?
Perfect. It takes a second. So now let's do this that Jeff was so excited about, which is let's use the room as a database. So let's say right now I'm gonna write something in, because this is gonna take a second. I'm gonna put it right here so I can see when it's done. So let's come right here, and let's say everyone that is in this meeting right now, it's a database. Each one of us, we have information associated to us. So let's say that I do select name from participants, which is everyone right here, that were not birth country US. What does this mean? That their birth country is not the US. This is just a quick, so just to wait a little bit. Well, definitely my name is here because I was not born here.
So how long is it going to take? Do we have a minute or two?
We definitely have some time, right? It takes like 5 minutes.
Okay,
A
so
little longer even.
as that processes for people, then we could play a little game. So I see all of you over on the side there, and we also have you all in the attendee list. And what we could do is we could pretend that we are all rows in a database. So all of us as rows in the database, the schema are the different details about us, like our name, or like our first name, or our last name, or our age, or if we've been to the event many times before. There can be all kinds of different categories, like the rows of the columns at the top of a spreadsheet, and then the rows. Each row is like one person, like one of us. So if we said we want to select from students, and this would be the students table, we're all the students today, select from students where first name is like A star. So like the letter A, starts with the letter A. So if we selected just the people whose name starts with the letter A, how many people in this class right now, how many of you would match? Let's see. So we've got 1. Anubahav Rawa and Anna. And who else?
3.
I don't see the third one.
Anthony, Anubhav, and Anna.
Yeah, so there you go. We'd have 3 matches. If we instead search for, let's say, select star from students where last name ends with O, how many matches would we get?
Or there would be a lot of information right there.
It would take a lot to figure out. Let's see. So there's Anna has an O at the end of her last name, severe O. Let's see. I think
Beginning with O or ending with O?
ends with O.
Ends with O, okay. So
Looks
again,
one,
Anna.
Yeah, only one match. So Anna and I were talking about this lab yesterday and about SQL, and one of the things that's sometimes difficult about teaching it or learning it is that many of the different queries you write will actually have an answer, even if the query was written wrong. So you might end up getting an answer, but it's not the answer you thought you were going to get. So always be careful when you're doing SQL queries to be, to think about what it is you're asking it to give you. Like I want all of the select star from students where student type is new, or something like that. And that would be, who are all the people who are new, who weren't here before. We've had 13 events last year under the School of Cloud title. Now we've got 11 more planned, including this one. So the people that are new would be just the people who haven't been here before. That's some of the people. And a database is a great way to keep track of things like that, like little extra columns about any one of the rows. If you had all that stuff written down on paper, it'd be really difficult to sort through. Look at the lab we're doing today. There were 24 million rows. If you imagine someone in the old days maybe would have a 3x5 index card or something for each different record, or something like that, and then sorting all of them and trying to find exactly the ones that match a certain criteria, that could take you a week, right? Or it could take a lot of people a shorter time, but still, it would be a big pain to sort through records. So databases really started from some of the largest problems that people had, and usually about people. When they were working on censuses, when they were trying to find information about every single person in the whole country, things like that, there are enough records that it becomes difficult to do just with paper. Yes, they would do it, but it would take a lot of people a lot of time. And there are many questions that they couldn't easily answer. But now with databases, you can easily answer even this, like historical data about taxi cab usage and stuff like that, or bike sharing, or other common like practice data sets. Like people wouldn't ever keep that many detailed records before because it was difficult to do so and to sort through the stuff. It looks like the instance completed. So let's head back over to Ana and see what she's got to share.
So we have the green check right here, which means that the instance is ready. So we can go to the next part. And so let's come back here and let's see if we did it properly. So let's check our progress. We're good. We created the SQL instance. So what we're gonna do right now is we're gonna take these two so you remember how we upload these two things right here into a bucket, and now we're gonna create in this SQL instance, we're gonna upload those tables, those files, those SVS file as tables right there. So let's open the Cloud Shell. The Cloud Shell, you can find it right here. So if you click here in the corner, it's gonna activate. Let's see what we get. And now, if you haven't used it, it's probably gonna you're gonna have a little thing that's gonna appear here. You're gonna have to click OK. And now in the lab, we can navigate directly to the part that says run the following command in Cloud Shell to connect to your SQL instance. So basically, with this right here, what we're doing is we're connecting to our instance, which the name is Quick Labs Demo, and the user that is connecting is ourselves. So we need to authorize the Cloud Shell to go to the instance. And now in a second, it's gonna ask us for the password. This is where the password comes in. I think I put 4 ones.
1111. That's a pretty creepy password.
Yeah, I do not recommend anyone to put that in anywhere, obviously.
Yeah, we should put 2222 instead. Nobody knows that one.
Okay, it's working. There you go. Now I have to put my password 1, 2, 3, 4. There you go. And now we are inside. So now basically this shell right here has access to our SQL instance right here. So let's start by creating a data set in a database. Sorry. So how we're gonna create a database? We're gonna do it with the keyword create, and then we're gonna specify that what we're creating is a database, and the name of the database is bike. So by running this, we're creating a database called bike. Now let's go to the lab and let's check that we did it properly. So far we have created the cloud storage bucket. Now we have uploaded the CSV files to the bucket, and now we have created the instance, and we have created the database. So right now we already completed the lab, but there is a lot of interesting things that we're gonna do right now. So I'm gonna wait 1 second in case that people got a little lost. Is everyone okay so far?
There's a question over in the chat, and the question is if there's any representation of tables, databases, and views in the squared box when we expand the tables. Do you know what that might be?
I don't under the square box when we expand for tables. I don't really understand.
Basically, when we expand a databases in the Bigquery, right? Might be it can be parked later. Not right now. It's important. Sorry for that. Over to you.
Oh, kind of like can you see it kind of like in this you're seeing exploring? Can you explore those databases in the same way? Is that kind of what you're asking, Kumar?
Yeah, if you see like there is a Ana clicked it says different type of. If you scroll down left, not there actually. It has a table with squared all dots. Sometimes it has an empty row, then table. So is there any difference there, or it's straightforward? In the left span in the Explorer box.
Oh, okay. So there, where you're seeing the table, the database, and the table, and
yeah.
So can you see the same kind of thing for the MySQL ones?
1 second, let me see. I'm databases right here. So if we click in database right here, now we see bike.
So is it possible to kind of dig in to it?
The thing is that so far we have only created the database. We don't have any tables or anything. So I don't have an answer. We may or we may not. So once we create the tables, we can explore that a little more. That's actually a really good question.
Yep.
That's a good question. But let's go back to the overview because we're gonna use this now. So we're gonna actually create a table, and now we're gonna upload the information that we have in those CSV files. So once we have the data there, we're gonna see if we can see it. I have no idea. I actually don't know. So now that we have the database, the database by created, let's now create the tables. So here, this statement right here, use bike. What it's doing is making sure we are in the right database. So let's say we had another database called I don't know, stations. If we wanted to query, if we wanted to see insights from that station database, we would need to use station, but we're using the database bike. And now we're creating a table. So you see how before we use create database, now we're doing create table. The name of the table is London 1, and the different columns are star station name and num. A star station name, it's gonna be a string, and the other column num is gonna be an integer. So basically, it's gonna be a schema very, very similar to this one. We're gonna have a star station name, which is strings, and num, which is an integer. So we create that first table, and now we are gonna create a very similar table, but the name of this table is London 2, and instead of star station name, it's gonna be any station name. The rest is all the same. So because we don't have any data in here, we just created it empty. If we try to see what's inside, so we do select everything from London 1. If we see this, it's going to tell us that this is an empty set. So basically there is nothing here. If we do the same for London 2, which is the other table, this is also going to be an empty set. There is nothing here. So let's now take the data from this bucket and add it into these two tables. So how are we going to do that? We're going to click on import, and now we're going to click on browse right here. This is the name of my bucket. We click on next, and now we're going to click on star station data. So star station data, the file format is SCV. The database name is bike, and now we're gonna put the information of this table. We're gonna put it in London 1. So let's import this. Gonna take a second. It's important right here. And now, yeah. Anyone has any questions?
I'm kind of stuck with the previous step where you activated the Cloud Shell.
Yeah, so to activate the Cloud Shell, you need to click right here.
Uh-huh.
Once you click there, here is here. So once you click right here in this corner, go down to this statement right here. With this statement, you're gonna connect to the cloud to the SQL instance. Did you run that already?
I think I did. So, could you show me which one? Google Cloud.
So did you call your instance with the same name?
No, I don't think I did.
So your instance right here, your SQL instance, what's the name that you gave to it?
The same one, the Quick Labs demo.
Good. So if you want, just do one thing. If you're having issues, just close this and start over. Like, just don't save it, start over.
Is just that little Cloud Shell box, not the entire thing.
Yeah.
Yeah. Of course. Use the Cloud Shell.
Over on the side there in the chat, I pasted the one-on-one link, so you can chat with me, and I'll walk you through. If you just do a screen share with me, I'll tell you what to click so you can make it through. So I'll try to help you solve that, if that helps. And then Ana, just don't go too quickly, and then we'll try to catch back up when it comes back over.
Yes, of course. So I don't know if there's more people that got lost, but basically click on the shell right here. Once the shells appear, you need to connect to your instance. You connect to your instance by running this one line here. And so you run it, and it's gonna take a couple seconds, and it's gonna ask you for your password, and you're gonna have to enter the root password that you set on the instance. And once it connects, you're gonna see a message like this one. You see, like, I wrote that, then I wrote my password right here, which no one can see, and then this message right here pops out. Once this message is basically telling you like the shell is connected to the SQL instance, and now we're gonna create the database called Bike. Once we have this database, we're gonna create the table right here, and then we're gonna create the other table London too. So is anyone else lost? Good. So we imported the star station name, and now we're gonna import the other one too. So we're gonna click on browse any station data. We're gonna select this data. The file format is an SCV. We want it in the bike database, and now we're gonna import it in London too. So we click on import. So do you remember when I clicked in here, I did select everything from London, and it told me that it was an empty set. So what I did right here, what I did right now is I put the information from this bucket, from the data that we downloaded before. I put it in London 1. So if we do now, if we ask the same question again, what information has London 1 does have? Now we have all these data right here that comes from the CSV file. And if we do the same with London 2, let's put a limit because we'll use 5 rows. We have the same thing. We have all the information from the other CSV file. So is everyone with me so far? I'm just gonna take this silence as a yes. Good, thank you very much, Kumar. So let's keep going. So what we're gonna do now is we're gonna learn some more new keywords, the delete keyword, for example. So if we come to our table right here, we can see how the first line, it's actually not what we want. What the first line is just the name, and it gives us 0 because this is just the column name. And if we go to London 1, we actually get the same output. So like both tables, the first row is a value that actually does not belong to the table. So we want to delete this one value. So how we're going to do that? We're going to write the statement delete. And now we're going to say from what table do we want to delete? We want to delete from London 1. And what's the filter that we want to do? We want to delete, well, actually, let me this piece is there. We want to delete the rows where the num column is equal to 0. Yeah, I really didn't want to do that. It's equal to 0. And this gives me, let's see what it does. I'm gonna go to London 1 again. And now that one row is not there anymore. So let's do the same thing for the other table, London 2. And we have also one row affected. We deleted one row, which is what we wanted. Okay, lastly, we just deleted one row. Now let's do the opposite. Instead of deleted, let's add a new row to this table. This is a little more fun. So the syntax is the following: insert into the table London 1, and now we need to specify what columns, what values we're gonna add. So we have a star station name, which is this first one with this first one column, and then num, which is the second column. What values do we want to input? We want to input on a star station name, test destination, and on num we want to add the number 1. So let's see. We did that for London 1, so let's do select everything from London 1. I need to add at the end this, otherwise it's gonna ask me to add something else. And now we can see here how we indeed inserted a new value. Let's say, for example, now instead of a star station name, test destination, we're gonna do test destination 2, and we're gonna add the number 11. So we run it, and we're gonna have here the test destination 2, number 11. So that's how we create new values. Okay, the last thing that we're gonna do is the union keyword. So before we run this whole chunk, let me go by part. So what union does is it takes two tables and it joins them together. So it puts one below the other one. So let's take this first query right here, and let's run and let's see what we get. So we're gonna select a star station name, and we're gonna call it top stations. And now we're gonna take also num from London, where number is greater than, let me see, 100,000, and we are gonna order it by top station in descending order, meaning the largest values first. And we're gonna get we get these values right here. Let me make this a little bigger. We get these values here. If we do the exact same thing with London 2, and instead of star station name, we get any station name, we're gonna get a similar table. So what we're doing in here is we're getting the top star stations and end stations from both tables, and we're gonna order it by top station descending. So we're gonna get the top values from both, and we're gonna, as we see right here, from the first column we had that Wormont Street was one of the most popular one with these many stations, and with these values right here. This one comes from the other table, and now we have Wellington Arc, Hyde Park, and this many, and this value, it's gonna be right here. So basically what we did is we took these two results and we joined them together, getting this bigger table right here. Okay, I don't think I explained myself very well, but does it make sense? Did you guys understand kind of like what we did? And so what we can see right here is that you see how we have repeated stations. all these stations is because they're very popular for people to start their trip, but also end their trip, because all of these are repeated in both of them, which means that all of them are very popular for people to get their bikes and also leave them there. So did you guys understand what New Union does?
Anna, so I was helping Sabra, and now it looks like people are about 7 minutes left
Yeah.
before the timer runs out.
No, but we're actually done with the lab right now. Like,
You guys finished?
congratulations.
Yeah. So you made it to the end. So what people have to do when they finish with the lab is they need to make sure they hit end lab before the timer goes to 0. If you wait until the timer goes to 0, even if you got 100 points, they don't record it as a success. And you need this one to be a success so that you can get the free month of access. Otherwise, I'll have to get you another code. You can still chat me and I'll try to get you another code if this, if you didn't pass this one. But anyway, it's really good if you do pass it. And look at the time, we're doing pretty good. We started at 6. It's now 7:45. That's Central Time. You might be on different time zones where you're at, but we learned something. We played around. We pretended we were a database. We did some selects, some inserts, and all kinds of things. And if we added a new student, it'd be like inserting a student into this database of students. And if a student left, then it would be like removing a student. How would you do that? We didn't learn about deleting anything yet. We only learned about how to add things or how to.
We actually did that a second ago. I think you were maybe helping.
Oh,
we learned how to delete rows and also how to insert new rows.
Cool.
Yeah. So let's end the lab. To answer a few more questions, I don't know. So there may be some other way to check it. But if we come here to database, we can see the bike database, but it can actually don't seem to really see how to like check the tables inside a bike as well as we see them in Bigquery. There may be a way, I just honestly don't know. So I'm gonna end the lab right here. Well, does anyone have any questions before I end the lab? Because then I don't have access to my GCP anymore.
Thank you for all the folks who did show up for that. Now that you've hit end lab, let's make sure everyone else hits end lab if they've got the 100%. If you've got the 100 out of 100, make sure you hit end lab so that you get the credits for this. And make sure you fill out this little survey thing and hit submit. And that's when they actually count it. And then you see then this thanks for reviewing the lab. Then it goes to /100, like it goes back to like being like
0.
Now they've recorded that she completed this lab. The next time she opens Quick Labs, she will have a monthly subscription listed instead of just having the credits. Now, I'd like to get people to work together as study groups. If you still are fighting this lab and you've got a couple minutes left, keep fighting. That's fine. But I want to do is put people into breakout rooms so then we can form study groups to be able to keep working on this stuff, not only today, but also over the next few weeks as we learn more about Google Cloud. And what I'm going to do is I'm going to put people into rooms of, I think, let's see, we've got 18 people, so I'll put 3 rooms of 6 people. And I'll put that for a good 5 minutes here so we can say hi, and we can, if you want, you can meet the other people that you're connected with, and then you can make study groups. Those are optional, of course. Also, I'm going to send, I'll put in the chat a link so people can go to that Saturday interview practice room on Clubhouse that I mentioned. Me and a PhD, Steve Fan, together we have a room where people practice every Saturday for 2 hours, behavioral interview questions, the kinds that they use for interviews at places like Facebook, Apple, Netflix, Amazon, Google, those sorts of companies. Now Facebook is called Meta, but you get the idea. And the best method, that STAR method that people use to answer those questions. So that's another benefit that you get from being involved in this. I want to help people not just learn, but also connect with others to share their knowledge and practice interviewing so that you can even get a job with it later. And I'm going to keep trying to build more resources and make this even more compelling. And that's what I'm going to do. So I'm going to set up four rooms, and then here we go. Let's see. Thanks again for attending the School of Cloud. Now take a look at some of our other videos, and see you back next time.